Hi all. We are going to complete the program. Complete the program in the sense, last class we discussed two out of three cases of deletion. What are those three cases of deletion? Deletion of a leaf node, deletion of a node with one child, deletion of a node with two children. We have completed deletion of a leaf node and then deletion of a node with one child, and that we completed these two cases that we completed. And today we are going to discuss in this video we are going to discuss about deletion of a node with two children. So deletion of a node with two children in the sense, consider in our example I am taking the node 35 as an example for this. So 35 is a node with two children. Left child is available, right child is available. The concept here is very simple. Either you can choose the smallest element from its right subtree. Right subtrees are the elements in right subtrees are 45, 90 and 55. Either you can choose the smallest element from its right subtree, or you can choose the largest element from its left subtree. So largest element from its left subtree in the sense, left subtree elements are 25, 10, 15 and 20. So these are the cases. So actually this part of the program contains only 2 or 3 lines, but logically you have to understand what we are going to do with this program. Here exactly what we are going to do is, if we are choosing the largest element from its left subtree, in the sense the largest element is 25. So we have to take 25 and place it, because 25 is the largest element, because 25 has no right subtree. So 25 is the largest element. So what we are going to do is, we are going to delete, actually we are going to delete 25, and we are replacing the instead of 35, 25 will be placed here. Likewise, if you are taking the largest element, smallest element from its right subtree, the smallest element from its right subtree is 45, because 45 is having no left subtree. So if there is a left subtree, then the leftmost element will be the smallest element. In this case, the leftmost element among these left subtree elements are 45. So 45, we are taking 45 and we are taking the value 45 and place it here, and what we are going to do is, we are going to delete this particular element. So what is the meaning of this? If you are going to delete this particular element, it's another process of deletion. So logically you have to think a little bit more, because it's a recursive function, because once you are going to delete a particular element, in the sense subsequently you are going to delete another element also. So that element data has also be deleted. So in our program I am going to write like this. We discuss the cases like deletion of a leaf node, that we completed. Deletion of a node with one left child, that also we completed. Deletion of a node having only one right child, also completed. The last thing is the deletion of a node with two children. This is the case. Deletion of a node with two children. So this is a case that we have for a discussion. In this case, very simple. You have two options. You can take either a smallest element from its right subtree, or you can choose the largest element from its left subtree. So here what I am going to do is, I am going to choose the smallest element. So that I told you, we just want to take the smallest element from its right subtree and placed it in the location where you have to change. Fortunately or unfortunately, I am choosing the element 35. So 35 is a root, but we are not going to replace the address of root, because we are not going to completely delete this particular node. It's a tactics. I don't want to delete this particular node's address 100. Instead of that, what I am doing is, I am going to find the smallest element from its right subtree. After that, once you identify the smallest element, what we are going to do is, we are going to collect that particular element, that is 45, in a temporary variable or a variable. After that, I am going to delete this particular node. Actually, our intention is to delete this particular node, but actually what we are doing is, we are going to delete this particular node and we are going to place 45 instead of 35. This is the work that we are going to do. So first step is to collect the smallest element. So that program that we already discussed, that is why I divided the program, or a modular thing, that is we divided the programs into small modules. So last videos we discussed how to identify the smallest element, how to identify the largest element. It's only because of this case. I discussed this one in the previous video. Please refer the previous video. Or if you want to find the largest element, that also that we discussed in the program. And after that we discuss the deletion also, how to delete. First search the element and then delete. This is a case. So this is a program. So actually we are going to write a simple program for this. K is a variable that I am using for collecting the smallest element. K is equal to what is the name of the function? I forgot the name of the function. Okay, smallest. Remember what are the parameters that we are passing? We are passing the address. Okay, so smallest of which address? Smallest of, we are going to find the smallest element from its right subtree. So right subtree address will be t tends to right. The smallest among the right subtree, or the largest element from the left subtree. That's a condition. So in my case, I am going to choose the smallest element from its right subtree. So what I did is smallest of t tends to right. That is a condition that I mentioned. Once you collected, so after that you will get the result, that value in the variable k. For example, 45 will be stored in the variable k. That is the output of the program that we already discussed, how to find the smallest element. After that, we are going to delete this particular node. So for that, what I am going to do is search of. Here we have that deletion function. What is that? First step is to identify where it is located. It's a continuous process, so I am using that function here. Yes, here. Del of address and element. So del of address is what? Root, because we don't want to, we are going to find this particular element from the root itself. Okay, after that it's a continuous process. Once it reaches here, it identifies where it is located. Element is greater than t tends to data. Likewise, it continues the process, and once it reaches the exact location, then delete one of t. This also that we discussed in the last classes. So it comes to the program and verify whether it's a leaf, verify whether it's a node with one child, whether it's a node with two children. Okay, that process is completed. Okay, because we already discussed and we wrote the program for that one also, so we are not going to discuss that one again. After that, what is next? We are going to replace the data. T tends to data equal to k. T tends to data equal to k. Very simple. Program is over. It's very simple. So I think all of you understand what I explained in this program. Actually, this is a 3-line program. You may see this like it's very simple program. Okay, it's a 3-line program. But actually, what is happening here is this 3-line completely explains the entire program. That is important thing, to find the smallest element. So it's another subpart of the program. So how to find the smallest element. Okay. So I just want to avoid all those confusions. That's why I divided the programs into small videos and explained, so that you will get that idea about how to find the smallest element and what's the use of the smallest element. So here we are using the smallest element. Instead of that, I can write in a different way, like largest of, that also is possible. Largest is the name of the function, I think, from which left subtree. Left. Anyway, we will get the value that will be stored in the variable k, and after that what you are doing is we are going to delete that element, and we are replacing they know exactly what we are going to delete. As per the user requirement, which element we are going to delete, that element will be replaced with the new element. So address is a internal part of the internal part. User is not bothering about user in the sense the end user. End user in the sense the person who is going to delete the element may be the user. So as a programmer, we are going to deal with the address. They don't know, the users don't know about whether we are deleting the address or whether we are deleting the element. They just want to reflect what the requirement they made, what the requirement they are given in the program. So that is completed. Okay, so this is a program. Please write this program, complete program by yourself, because we discussed separately. We discussed in a with a small videos, because this is a big program and a little bit confusing. So I just want to avoid those confusions. That is why I made small videos for all this entire program. You can watch all the entire program and write a program by yourself. And if you have any doubt, please call me. Okay, thank you.